Okay, so I'm going to do experimental and theoretical probability because there are a lot of students asking for this one. So what you have to remember is that ALEKS is tricky, first of all, but the experimental probability, usually it's has the explanation. So I'm going to show you what to look for with the difference between experimental probability and theoretical. So what I recommend that you do is to write down this right here and have it right next to you so that you can remember every time they switch the situation or they switch the type of problem that it is and the situation. So definitely reading all of the important information up here, 25 trials. We're going from 0 to 9. So that's 10. It's 10 possible ways of getting, whatever number is in the list. Okay. So this question is asking, and I like to go straight to the question. Compute the experimental probability of getting a 0. So here we have the number of times getting a 0 is 4. And then there's 25 trials, so it's 4 divided by 25. And then whatever that decimal is, you can see it below. And then with theoretical probability, so with the theoretical probability, you take the number of ways that you would get something of the digits 0 through 9. So then that would be 10 possibilities. So there's only one instance of that, which is there. So you would do, for theoretical, be 1 divided by 10. And just try to remember that the experimental and theoretical probability, they're similar. They should be similar. Okay? And then the explanation here is below. So what usually is going to be your answer for part C is that as the number of trials increase, we expect the experimental and theoretical probabilities to become closer, though they might not be equal. Okay? Sometimes they can be equal, and then there's the result down there. And again, use this video. You can pause it and whatnot. Okay, so from Deborah's results, compute the experimental probability of rolling an even number. So where are your even numbers? 2, 4, and 6. So what corresponds to that would be, well, actually you can see it below, but 81 plus 83 plus 85, just in case you can't see it in the video, over 500. And then the decimal is 0.498. And then the theoretical rolling an even number would again be out of how many times it happened. So there are 6 outcomes, and then there are 3 instances of even numbers. So that would be the 3 out of 6, which is 1/2, which is 0.500. And again, the larger the number of rolls, the greater the likelihood that the experimental probability will be close to the theoretical probability. You can see that below. Okay. Let's try another. So a spinner with 5 equally sized slices has 3 yellow slices, 1 red, 1 blue, and you see 3 yellow. Yoko spun the dial 25 times and got the following results. So what is the possibility that you land on yellow? Well, it would be 12 times, right? Out of all of the outcomes. I'm sorry, the number of spins, which is 25. And I have no idea what that decimal is. 0.480. And then, assuming the spinner is fair, compute the theoretical probability of landing on yellow. Well, there are 1, 2, 3, 4, 5, right? And there are 3 chances of getting yellow. So since there were 1, 2, 3, 4, 5 slices, and I have no idea what that decimal is, 0.600. Now, as you can see, these are a low number of spins. It's not a lot. Okay, so assuming the spinner is fair, choose the statement. As the number of spins increases, we expect experimental and theoretical probabilities to become farther. Or no, that's not right. It's as the number of spins increases, we expect the experimental and theoretical probabilities to become closer. And you can see that down here. Let's do one more. Okay, so here's the state lottery. There's 50 trials, 0 through 9. From the results, compute the experimental probability of getting a 6 or a 9. So the probability of getting a 6 or a 9 is 8 plus 6. 8 plus 6 over, how many was it? 50. So that would be 14 out of 50, which you can do the decimal there. And assuming that the machine is fair, compute the theoretical probability of getting a 6 or a 9. So there would be 2 chances out of 10, which I know that would be, no, let me get my calculator. 14 divided by 50 is, so this is actually 0.28. And then 2 out of 10, 0.2. Okay, so as the number of trials increase, we expect the experimental and theoretical probabilities to become closer, though they might not be equal. So I hope this helps. Thank you for watching. Don't forget to hit like, share, and subscribe, and let me know what you would like to see in the comments.